But our recent biggest sort of launch was with a company called Total Jobs, and that enables you to search for a job from your front door that's within a commutable distance, whether that's 1 hour, hour and a half, or 45 minutes, whatever you set.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Charlie Davies, and he is the founder and CEO of the Travel Time platform. So this is a platform that lets you search for locations based on the time it takes to get there. So a very simplistic example would be you're in your apartment and you want to go to the nearest swimming pool. Not nearest in terms of straight line distance, but nearest in terms of travel time. This is the kind of problem that the Travel Time platform is solving. Of course, there are 100 other use cases, and we'll get into those in the interview. But before we dive into the actual interview, I'd like to take a couple of seconds to remind you that this podcast is sponsored by Hive Mapper. That's Hive as in Beehive Mapper. And this is the platform that lets you upload video footage to the cloud and have it automatically converted into 3D geospatial layers. The platform itself does a whole lot more, and it's really interesting. If you're flying drones or working with aerial footage or interested in using it in your business or your day-to-day work, I highly recommend you check them out. Okay, on with the interview. Welcome to the podcast, Charlie. Now, for those listeners that haven't met you before, you are the founder and CEO of a company called a platform, I should say, called the Travel Time platform. And so this has a lot to do with geospatial. It has a lot to do with mapping. Yeah, I'm really looking forward to diving in and learning more about it. But before we get into that, could you give me a little bit of background about yourself? How did you get involved in the Travel Time platform?
Sure, no, it's a pleasure to be here, and thanks so much for having me. It's a great honour to be on your podcast with you today, Dan. There's many stories around how I sort of ended up doing what I'm doing, but essentially, I was working in a company that was working heavily on local search. So this idea that two sides of a coin, where you've got people like me and you in our everyday life using the web and mobile to find things in our real outdoor environment. So away from our laptops, away from our phones, trying to find, the hotel we want to stay in, the property we want to live in, the job we want to work in. And we were working at this company and trying to figure out better ways of doing it. And that sounds like such a big mandate. Here's something, make it better. And we were working on several different ideas, and sadly, although that company had some great people in it, and it was a great idea, it didn't work out. So I was left back in my parents' loft with some sort of kernels of ideas in my mind, and one of them was this idea that I had while in a traffic jam on the M4, one of the beautiful motorways in the UK. And there was lots of traffic, and I was thinking, we're obsessed by distance. Every site that we were using, every site that we had looked at to develop, or concepts or wireframes, there was always two different methodologies to deciding what to show someone. And that was either a municipality, like the area of London or Islington or Camden, or a city like Southampton. And those places exist mainly because they were areas that we could tax people on. And that, in that sort of grown up in the sales model online for local search. And then the other one was distance. And distance is just the most useless way of searching for a human, for you and I, And I just thought, stuck in this traffic jam, when I'm searching for something that I need to get to, or it needs to get to me, then travel time is actually the most important unit to measure that by. So, very naively, we decided that we would go and build what we now very imaginatively call the Travel Time platform, in order to do exactly that. We have this platform that enables you and I to search the world around us and data around us in exactly the same way that we use it, by travel time instead of distance. And there's a lot of other stories in between, like where that idea came from and where we find ourselves today. But that's essentially how myself, Charlie Davies, came to be doing what I'm doing here today and talking to you about.
So you realize that accessibility to different areas, to different things, to to whatever is not necessarily based on distance. It's not necessarily based on a straight line distance between where I am and where I'm trying to get to. So this is part of the problem you're solving. And I think the other part of the problem you're solving is the recognition that there is so much data out there that we need some way of filtering it. So it feels like you
Yeah.
saw these two things here and slammed them together and came up with the travel time platform. Would that be a fair assumption?
Yeah, I mean, as much as Red Bull have ploughed into the advertising leviathans that they've become, um, I've never grown wings. I can't fly in a straight line, and I've never met anyone else that could do either. So, we're at the mercy of those transport networks around us. And when we're trying to, interpolate data around us, as people, there's so much choice. There's so much out there. If you do sort of any location-based search online, there's usually thousands, if not tens of thousands, if not hundreds of thousands of results. And how do you find out that the one that you're looking at is the most relevant for you at that time? And it wasn't just the amount of data out there in terms of what could be searched, but when you put the element of travel time in there, doing a distance-based search, there's a number of different methodologies to do it, but is fairly straightforward especially if you treat the world as a flat plane. And to develop what we've done, we've had to actually amass huge amounts of transport data ourselves in order to build it in such a way that people can plug into it and say, if they're a property company or they're just trying to find something for the weekend or using one of our tools in something like QGIS, that they can very very easily say, how far can I get within half an hour by public transport, walking, driving, cycling at different times of day, and then overlaying that with whatever data they want.
So I'm really glad that you mentioned the data side of things, because that's obviously a huge piece of the puzzle here, and I really want to talk about that a little bit later on. But
Sure.
just for the moment, I want to stay with this idea of travel time and how it's bringing more relevant search results to us,
Yeah.
because it feels like you're putting a whole different spin on that first law of geography, which is all things are related, but near things are more related. And
Yeah.
it feels like we could also add time to that. They also need to be related in time, and perhaps time here could be a reflection of accessibility and the amount of effort taken to move things from one place to the other, that kind of thing. So I think this is a really interesting concept.
Yeah. And it's a great phrase that, near things are more important. Well, what's defined near? If we're in the middle of a flat field, near is going to be anywhere within, let's say, a 50-meter radial around us, and then a mile, and then 2 miles, and just keep on going. But humans have built this huge civilization across across the globe, and that's put a level of complexity around what near means. Near is so many different things now. I mean, if you take right up to what air travel is, reducing the amount of time that we can move around the globe. But closer to home, I live in central London, and near to me is so much more important with travel time, because I can get so much further north and south from where I live than I can east or west in the same amount of time. And when we started with this idea, it was actually to develop a consumer offering. We wanted to go and build a tool that we could use in our everyday lives to find stuff around us that was nearby and relevant. And the problem with distance-based search, and that defining near by miles or kilometers, is that you're inevitably going to find lots of stuff inside of that radial, that circle, that you just can't get to. So, from where I am right now, there's certain parts of London that if I did a 3 mile search, which isn't really that far, then there's going to be loads of stuff that I can't get to within maybe 30 minutes or 45 minutes. But there's the other value of what we do is not just talking about, removing the noise inside of a distance-based search, but all the opportunities that you would never think about. So, if you were standing at, say, King's Cross Station right now, and you were saying, what could I do within 45 minutes? You could be, 30, 50 miles outside of London quite quickly, and then find yourself in an area, I don't know, like Milton Keynes, if you went from Euston, and taking those islands that you find that would be outside of that original distance-based search, are even more important. They're more valuable to you because there are areas that you just wouldn't have considered. And to include them on the distance-based search, if you just increase that circle size, you're just going to increase the amount of noise that's there. So yeah, it's fascinating to look at some of the different ways that urban areas can open themselves up and the accessibility of them when you look at them through the prism of time and not distance.
Yeah, and when I visit your website, you have all these amazing images there of these. You describe them as travel time islands,
Yeah,
and for me, they resemble the results of a viewshed analysis. So they're kind of they are islands. There's oftentimes a huge polygon with holes in it, and polygons that
yeah.
exist outside that original one or the biggest one. Yeah, and it really sort of opens your eyes to what is possible, and it shows these places that are very easily accessible, and the ones that are perhaps closer to you in distance are not necessarily so accessible. It's a really, I think it's a really interesting thing to see. It's a really interesting visual way of describing what what the opportunities are in these particular areas.
Yeah, and it's all about sort of making a decision as well, because it can be if you're near like a peninsula or a river and you can't just jump over the river. So something that could appear, even if you're right there and then line of sight looking at it, it can appear very close. I could I can almost reach out and touch it, but it's going to take me, say, 15 minutes to walk down the road, over the bridge, and then back over to the same place and sort of look back on myself in the same position I was in. So it doesn't even have to be that much of a travel time to sort of make it more relevant and human to what we can actually do in the geography that we find ourselves in.
So I think you've done a really amazing job of describing the problem and how you're solving it and some of the results that come out of this process. I'd like to move on now and perhaps talk a little bit about the data that's
Sure.
involved because I'm imagining this is a huge piece of the puzzle.
Yeah, it's one of our first challenges about developing what we've developed is always to us about speed. So my background is, I'm not a geographer. I'm not a GIS specialist. Although my vocabulary is getting better by the day, it's more. I was focused on how can people uh, use search in a more interesting way. So our focus was always on consumer sites, and it had to be quick because if things are slow online, people just tend not to use them. And our first challenge was, yeah, like I said, making that really performant. And I remember doing one of our first big demos, and it took about 2 minutes to do what we can now do in about 100 milliseconds. And beyond that, there's infrastructure and the teams around us to make sure that when you do a search in Sydney or San Francisco or Tokyo or Cape Town, that there is as fast. But as we've developed this beyond London, beyond the UK, beyond Europe, is data. And there's no way to do a good travel time search unless you have good data. And that's been a big challenge for us because we've had to go and source some of that data. There's lots of open data, but the problem sometimes with open data is that there's no such thing as a free lunch when it comes down to it. So that data might be in different formats. It might be incorrect. It might be invalid, and there's a lot of cleaning and processing that we have to do to that data, as well as test it to make sure that when you sort of put it on a map and do a route and then put it into our travel time platform, that it returns results that you'd expect. And one of the big challenges we've had around that has been the public transport data. There is no source of truth in this world, as far as I know, as far as I've been able to find, that says this is the transport operators that are in this city, this country, this town, this area, so that you can feel confident that you've got all of the operators in that area. And it's not just operators, it's also sometimes private services. South Africa has a huge amount of private services that are almost used as public services. And amassing that data for us has been a big challenge. We've got really good at it and we'll get much better. But the data side, you can't do what we do without having the best data possible.
So when I think about data that might be applicable to solving these kinds of problems, I for sure think about infrastructure, roads, buildings,
Mm,
that kind of thing, bike lanes, and you mentioned it before too, public transport, other kinds
yeah.
of transport networks. What are some of the data sets that perhaps someone like me wouldn't think of initially that are really, really important for this?
One of the ones that I've been working on recently is the combination of different modes. So there's been lots of new services. I'm going to talk about London because that's where I spend the majority of my time. But services like on-demand bikes. In the UK we started with we called them Boris bikes, but bikes that were at different stations. But now you're having a number of different services like Lime and Uber with the Uber jump bikes around, really changing the interchangeable sort of intermobility. So, if I get off at a tube station, maybe I'm not just walking now, but I can actually cycle up the road much, much faster. So understanding the likelihood of where the positioning of those bikes is going to be can really change how you look at a city, because most of the time, if you're using metro services in an urban area, you can't take your bike or anything else on there. But now there are services that you can append in order to do that. So for me, that's been a really interesting one, and sort of looking at how accessible or how to search the city around us. But there's so many data sets out there that you can add in, and you sort of get into the world of the law of diminishing returns. I've been asked so many things in so many different meetings. I got asked once for horse riding, whether we would do that, and I think we've moved on slightly from there. Weather conditions. It's really interesting, but because most of our stuff is about predictive modeling and what I'm going to do tomorrow or the next day or in a year, over the next year or two, it's not so much there. I mean, congestion data can be really interesting because people will actually make a choice. If someone's doing a daily commute, they may actually take a slower route, knowing that the quality of their journey would be better as well. So, we could keep adding, I think, we'll probably never stop adding different data sets to the model to make it more realistic, to make it more closer to what we're doing in our everyday lives. But I think, yeah, like I said, the law of diminishing returns really comes in when you've got too much data to manage and the results that you're displaying aren't really that much better as a result of it.
So you talked about all the different modes of transport there that were possible, and I understand that if there's service that are available, you need to sort of take those into consideration. But how, as a user, how do I say, well, I'd like to walk, I'd like to take a bike from here to here? Do I get different results depending on how I am traveling?
Yeah, take one of our recent bigger clients. So we make our platform available to sort of analytics departments. So that's people in business who who are sort of making decisions based on locations. So where should I put my office? Where should I open my retail store? Should I open or close this hospital for population growth in the future? And we embed those into tools like QGIS, ArcGIS, Ultrix. But then, our biggest markets are in the consumer sites. So in the UK, we have lots of property sites, but our recent biggest sort of launch was with a company called Total Jobs, and that enables you to search for a job from your front door that's within a commutable distance, whether that's 1 hour, hour and a half, or 45 minutes, whatever you set. And it's really interesting actually because the first iterations we did of this, we gave every option that you could have on our API. So how much time would you like to walk to the bus stop or your train stop? How much time would you like to be on public transport for? How much time would you like to walk the other end? What exact time of day would you like to arrive at the office? And it just became far too much data. When you look at route description and how you define a route, how you plan a route, you can really get lost in the detail. And the detail is all of those things I just described. But the value of what you want is to understand very quickly maps and the data that's being produced by this mapping engine back to the users. So on the Total Job site, you actually don't get an option at the moment of what mode of transport you want. It actually actively selects which mode of transport would be best for you to go onto that specific job, and it gives you the travel time that you would use in order to get there. So it's not just saying everything within an hour and a half; it's giving you the exact time to each of those jobs as well. So it's about understanding huge amounts of data, and taking the guesswork out of that, presenting it back to the user when they see those lists or those maps coming back, and for them to go, oh, cool, I can make a decision much quicker without having to, copy the address, putting it into Google Maps or something, doing an A to B route, remembering it, going back into the platform, doing another search, finding another result. We just completely remove that guesswork from a user trying to understand what's in front of them, really.
And I think that's the really amazing thing about maps is they can give you that overview really quickly. And I think sometimes we forget as practitioners in this space that we're not talking about data sheets. We're using a map for a reason because we're trying to give a visual overview so people can make that decision. And we've done the hard work for them. We've filtered out the data and we're showing them things that are relevant to them and not overwhelming them with every possible option.
Yeah, and I find, like I said, I didn't study maps before doing this, and I don't pretend to be like a GIS specialist or something, but I am just fascinated by the use of maps and how people understand them and how people use them. There are so many maps online, I think, that are there just to sort of make someone feel like they're in the right place, but they don't fully understand what's in front of them. So I always sort of use this example of taking things away from a map, but you still feeling safe that you know what you're looking at. London's a great example because we've got the River Thames that sort of ebbs and flows in this wonderful snake-like format over, through the middle of the city. And if I start removing things but keep that, most people would say, "Oh, that's London. That's great." And when you're, looking at a screen and seeing all the results in front of you, you put markers on a map or you put a map on, and actually when you ask someone to really look at it and say, what do they know that it's in London, and maybe they know it's in North London, South London, West, whatever it is, but they actually really spend quite a lot of time trying to figure out what each result means to them. And that's a bit of a problem if you're trying to get someone to sort of, do something with the results that you're showing them. I had this thing that I used to call spinning pavements, where mobile mapping is just like amazing. You can pull out your phone, find out exactly where you are, and then find out exactly where you want to get to once you've got the address. And you can see this blue dot on a map in front of you. It's literally in the palm of your hands. And maybe the compass is working to a degree and it's telling you you're facing in one direction. But I used to call it spinning pavements, where you just have someone looking down at their phone, spinning on the pavement, trying to orientate themselves to where they are. And they've got the most detailed map in front of them. They might have, the buildings around them, the building name, the street name, even the direction of traffic, that it's a one-way street. So much data, but the cognitive decision making around knowing exactly where you are was just completely lost. And I find, like, the GIS world, where maps have to be so detailed, it's this scientific methodology about recording the environment that we're in so we can reproduce it in different scenarios and different procedures. But when it comes down to people, the people that are using these things around us, they really don't interpret all that data. They just sort of take the bits that they need and get on with their everyday. In a way, people are their own sort of, I don't know, their own GIS expert in their own world. We all do our own routes each day. We know exactly, we're those local experts on what we do. We know that if we leave 5 minutes earlier, we'll have a seat on the train, or 10 minutes earlier, and we won't get caught at that pinch point in traffic. And, as we've been collecting all this data, we can't use all that local information because, that's what people know and people do. But I am always amazed that, if you actually take data away, and you just leave what someone needs, they can actually make a quicker decision and derive value from it far quicker. Yeah, I can talk about this stuff for ages, but it's like the London Tube map. It's a map that is close to reality, but not attached to the physical reality. So it's relative to each of the stations, and when you look at it, you can understand it. I never used to have a favorite map, but I guess I do now, and they would be those pilgrim maps. And pilgrim maps were used by people on their religious journeys to go and visit, various religious locations. And it would say to you, go towards this big tree, and when you get to that tree, find that big hill, and when you get to that big hill, keep, find the next big landmark and keep going. And these maps, they're not maps. They're not maps as we would look at, a map on a screen or on a piece of paper. but they're instructions to use the world around us. And that's what I think, maps are. That's what they should do, is they should inform people and tell people the information around them so that they can better make a decision. And that's, again, the core of what we're trying to do as well, is remove all of that guesswork. Just give enough information so that someone can actually make a decision with the data that you give them. I think it's just fascinating how, you look at, we're looking at our screens all day with maps, and then you look outside your window and there's people outside using the world without even thinking about it. But, we all have to use the environment around us. We're all using the world, and therefore, the data that all those maps are based on.
I think you've done a really great job of sort of talking about some of the use cases, and it feels like a lot of it's revolving around that idea of making better decisions based on better data and giving people that really quick sort of overview. Where are we? What's around me? What are my options from here? And this is, of course, is a perfect use case for maps. But when I first saw your site and started to read a little bit more about what you do, it occurred to me that there's a whole bunch of use cases here. We talked briefly before about some of the integrations that you have to QGIS and ArcGIS and presumably many other mapping platforms. So obviously the geospatial specialists in the room will be able to see the potential there. But I could also imagine things like proximity marketing. I could imagine doing some kind of modeling the world, like, okay, so this is these are your options here and now, but if we shifted the world, if we added in new streets or new public transport, we would get different results. Do you do any of that kind of work as well?
Yeah, we do, and we have in the past. So I think I mentioned earlier on that when we had our first iteration of what we do, it was clunky and slow, but it showed value in the sort of end result. And we found ourselves in this GIS market where people were using our data, and inevitably we got asked the question of what would it look like in the future. And there's a number of sort of fantastic sort of infrastructure developments across the world at the moment. I'm going to have to go back to London again because of Crossrail, huge development of a train line, sorry. And we had lots of people ask us, can you model this? Can you map this? And we looked at some of the initial mappings that have been done actually by Crossrail itself, and they were a line across a map, and it sort of showed where the stations would be. And we thought we could do a bit better. So what we did is we took as much information as we could find at the time. And that's got better as we've sort of gone into the closer to Crossrail being a real thing, and it actually opening. And understanding, when the trains are going to leave, how fast the trains are going to be, when they're going to arrive, etc., and integrating the future into a model that someone can use right now, but they can use it in the tools that they're already using. So they don't have to, import a model into their own workstation, process all the data, try and figure it out for themselves. They can just, turn a switch and look and say, right, what's London going to be like in 2025? Or what's the Paris Metro going to look like in 2030? And that can be really fascinating to look at how the city would change, because it is fundamentally changing the city. It may not look like it, but it changes how you could use it, where you could live, where you could work, where you could, meet your friends after work or do something on the weekend. And it's also really interesting for analysts and GIS specialists, because they can advise clients and the people that they're working with to make better decisions about opening a retail location here, because in the future it's going to get a lot of footfall. Or a property developer saying, look, we can build housing here because in the future it's going to be pretty accessible, not just because it's near the station, but it's near a station that intersects with that new line. So there'd be a lot more sort of throughput on that network at that time. And that's a really fascinating one. We don't allow people to edit the platform on the go. I mean, there are some toolings out there that do that. But if you want to see what London would look like with Crossrail, you can just use our data in a couple of seconds, well, actually less than a second, analyze your data against it.
That sounds like a really fascinating use case to me. I love the idea of being able to speculate based on how the city's going to change, how these physical changes we make to our infrastructure are really going to affect the city, and of course, ultimately the people that live in there and their lives, the way they spend their lives, and the amount of time they spend on transporting themselves back and forth to different places.
Yeah, I mean, time's a really interesting thing because it's not a commodity that you can, offset between your days. we only have a certain amount of time per day, per week, per month, per year, per sort of lifetime. And it's really important to understand that we're not only using our current environment in a way that we can, maximize the amount of time to do the things that we really care about, that we want to do, but in the future, that we're building transport networks and we're looking at things in a way that we can optimize what we're doing. We're not going to try and slow people down and take time away from them, but perhaps even, that gift of giving time back, when you find yourself that you actually have some spare time to do things. And yeah, it's not, I wish I had a better way to describe it, but it's not a commodity that you can trade. So it's one of the most important, valuable things we've got.
Completely agree. I've just got a couple more questions for you. And the first one is about, so obviously we talked a lot about London, we talked a little bit about Europe. Is this available in other places? Is it available in the US, Canada, in Asia? And I'm assuming when we start talking in different cultures, we have different rules around data. Has there been any sort of challenges you've run into with respect to that?
Yeah, yes, absolutely. A car is a car, a train is a train, a bike is a bike, and that object, that thing that we've built, they behave in the same way. A car travels down a road, a train goes along tracks, a bike is two wheels, and someone sits upon it and moves themselves around. But there's a huge different, cultural element about how people actually use that. And what we've tried to do is develop sort of the human way of using these vehicles, not just understanding what the vehicle can do. So we know that, when you look at sort of a drive time model, we take into account where someone could safely stop and get out of their car, because there's no point just understanding that halfway down a highway or a motorway you can just stop, because you can't safely stop. The car could stop, and if you're just looking at a drive time analysis for a road and saying, hey, look, this is half an hour and we're just going to stop, well, that's not something that's going to be helpful to that individual. It might be helpful to understand, I don't know, if your electric vehicle battery's going to run out, and you want to see how far you can get at the maximum, using the maximum of it. But there's so many different ways. So we had to add cycling and public transport access in the Netherlands, because obviously in the Netherlands, I don't know if you ever walked around Amsterdam, but bikes are king. If you if you're not looking left, right, up and down, you're going to get sort of run over by a bike. And they rule the roads and they take priority. In other cities, they don't. In the US, cars are so much more popular than in Europe with public transport, because of the historic investment of governments being differently aligned. And there's a huge amount of work that we do in trying to understand that. I wish I could say that I've been to every city where we have data and I've spent time with a notebook walking around, going through the detail of how people are using it. But it's a really important thing to get onto. I mean, another small one is, a lot of the trains in the UK have this thing where the doors shut 30 seconds before departure. Other countries, as the train's leaving the platform, you can grab onto it and on you go. And that just is something that would never happen in the UK, but would happen in other countries. And, although the data and maybe the maths stays the same, we're looking at, when something leaves, when something arrives, but understanding how people, how human beings, how you and I would interact with that is another level of complexity, but also another level of making it more interesting and useful.
You're obviously someone who's spent a lot of time collecting data from all over the world, and I've often heard a few sort of rumors about different regions in the world and some of the challenges around data. For example, I've heard that in Asia that sometimes things are a little bit offset, so people can't get the exact picture. And I know there's some challenges around addressing in India, and I'm sure there are in lots of other countries. Can you say a few words about that?
Yeah, I was fascinated to learn that all the addresses, all the lat longs in China are incorrect, because they have this sort of algorithm that changes them. So, when you think you're looking at the exact object on a map, it's not really there. I mean, we can't host data in China because it would have to be through a joint venture, and it'd be far too much effort for a company our size to do that. Other data sets, for example, in the UK, there's a mandate where we've got to release all the public transport data, same in the Netherlands. But I mentioned South Africa earlier on, where there's loads of private services, or just someone, driving their minibus route, and it's used every day by thousands of people, but it's not a documented route. It's not part of a government service. It's just how people are using the world around them and using all the different modes that are available to them. And trying to understand that en masse is complex. You can't always completely solve it from data. So one of the things that we try and do is, get feedback from our clients and our clients' users, and then try and ingest that back into what we do, but then also update the data sets that we're using as well. So there's sort of constant circle of data going around. It is really tough. I mean, like I said earlier on, there's no direct source of truth for all the public transport data in the world. We've had to go out and build our own lists and build our own sort of data sets around that. In India and its train network is just the most fascinating one of the most fascinating train networks in the world. I never thought I'd say something like that, but I'm almost like a digital train spotter now. And trying to understand how you take the data from that, how much data you need to make a service useful. We're not looking at optimizing the network itself. We're just looking at showing people that they can interpret that data or using that data set with other data sets in a meaningful way. And we'll never finish. This will never be a finished project. We'll just have to keep going.
So I think you've done a really amazing job of talking about the use cases, some of the challenges around them, and I can see so many more use cases out there. I can see so much potential in this. But when you look out into the future, what are the things or the use cases perhaps that you're most excited about?
I think there is going to be even more data at our fingertips that we can use to sort of interpret and then provide more useful services to people. I think that the 5G and I know there's so many buzzwords. You get sort of buzzword central of these things, but IoT and understanding that there's various congestion on roads or certain public transport networks are congested at certain times. Air quality, should I avoid certain areas, and how can we design a route around that if I'm cycling at various times of day? There's going to be so much more data coming out, and obviously huge amount of computing power, which is becoming cheaper by the day and more powerful as well. And when you sort of overlay those, the amount of data that we can just allow people to make those better decisions. But the complex side of that is going to be trying to figure out where we can find the value in that to provide the services that we're doing. And it's something that, sometimes, keeps me going and thinking, what other data can we add? What's the next data set out there that's going to be available to us, so that when people look at maps, when they look at locations, that maybe we can help them sort of make a decision faster or a better decision for them.
Charlie, I really want to thank you for taking the time to do this interview with me, for coming along here and teaching us all a little something about travel time and its importance and the potential use cases of it. I really appreciate it. So we've mentioned the name of the platform a few times, so people will be able to search that and find that if they're interested. But is there anywhere else they can go to follow up with you or get in touch with you?
Yeah, look, my email address is charlie@iglis.com. Feel free to email me directly if you've got some feedback on our platform, you've got any more questions. And if you want to have a quick look at the app, we have an app that you can test our data on. That very simply is just app.traveltime.me. And if you punch that into your mobile browser or your web browser on your laptop or your desktop, you can immediately start playing with our data and seeing what it does. And I just want to say, Dan, it's been an absolute pleasure talking to you as well. And thanks so much for inviting me on here. I feel very honoured, and amongst lots of other people that you've interviewed. And it's been a really great pleasure.
That's really nice to hear. Thanks so much.
No worries. Thanks.
So at the top of this interview, I talked a little bit about my sponsor, HiveMapper, and I mentioned about how you can upload video footage to the cloud and have it processed to 3D mapping layers. But what I didn't mention is that they've got this really cool feature that also lets you segment images. And this is done automatically. So there's no training sets required, there's no pixel signatures required, and it's repeatable. So I could do this for every single layer that HiveMapper creates for me, and I can automatically segment images into show me all the buildings, show me all the trees, show me all the water, where is the pavements. And they have another really cool group there, which is called mobile, and this is all the things that can be moved, such as vehicles, boats, cars, aeroplanes, people, and animals. I have no clue how they do it, but I think it's cool. It's worth checking out. And that's it for another episode of the Mapscaping Podcast. My name is Daniel, and I want to remind you that you are more than welcome to reach out to me for whatever reason on social media. To do so, you'll find some useful links in the show notes of this episode. I would really love to hear from you. Thanks for listening. It's much appreciated, and I'll see you next week. Bye.